Hello everyone. So today we're going to go over section 0.7, Trigonometry Part 1. So here we have a unit circle, and on it we've drawn cosine, sine, tangent, cotangent, secant, and cosecant. So all of these have been defined as a different length. And it is important to note that there are three right triangles here. So here's the first one. And then we have a second one involving tangent, and a third involving cotangent. Okay, so the first triangle, the one involving cosine alpha, sine alpha, and 1, this one right here, is also drawn on the left. The second triangle, the one involving tangent, so the largest one, we can also get that triangle by dividing every one of these numbers here, or ratios, by cosine. So what will happen is then we have sine alpha over cosine alpha, which is of course tangent alpha. Here we have cosine alpha divided by cosine alpha, which of course is just 1. And finally, on the left-hand side, we have 1 over cosine alpha, which gives us secant alpha. Which of course is also drawn on the diagram on the right. Okay, similarly, if we divide all three sides by sine alpha, then we have the following. The first will be 1 over sine alpha. And we know, sorry about that. And this is, of course, cosecant alpha. Here we have sine alpha divided by sine alpha, which of course is just 1. And finally, we have cosine alpha divided by sine alpha, which is cotangent alpha. Now, what is also important to note is that these three right triangles have associated Pythagorean identities. So the first one is very familiar. It's just going to be cosine square alpha plus sine square alpha is equal to 1. The second one, we have 1 squared plus tangent alpha squared is equal to secant alpha squared. And finally, the last one we have is cotangent alpha squared, so the whole thing squared, plus 1 is equal to cosecant alpha all squared. Okay, so the second part of trigonometry that we should look at or review is radian measure. Okay, recall that we have the formula A is equal to r theta. So in this case, if we are to find the arc length from A to B, we simply have the radius of 12 and the angle theta, which should be in radian measure, and we know that 60 degree is pi over 3. So this would be 12 times pi over 3, which means the arc length A is 4 pi. Right here. In the second diagram on the right, we have very similar scenario. So once again, we have A is equal to r theta. In this case, the radius is 1, so that's just going to be 1 here. And then the angle theta is already in radians, so that will be just 3 pi over 5, which means the arc length here is just going to be 3 pi over 5. And that's right here. All right, so from there, we can also use what we know about Radian Measure to find exact values of trigonometric ratios without using a calculator. So here, for example, it's going to go ahead and draw the special triangle that's involved here. And it is the pi over 4, pi over 4, pi over 2 triangle. Let's go ahead and do that. So this is pi over 4. This is pi over 4 as well. Pi over 2 here. And the 3 side lengths will be 1. And then we have 1 over root 2. And 1 over root 2. So this will be our special triangle that we're going to use. And let's go ahead and rewrite. So in order to find the trigonometric ratio here, we can simply find cosine 11 pi over 4 and then take the reciprocal. So we know that 11 pi over 4 is in quadrant 2. And in quadrant 2, we know that cosine theta is less than 0. And we know that the reference angle is pi over 4. So from there, we can simply find the value of cosine pi over 4. So we know that cosine pi over 4, based on the special triangle that we have on the left, is going to be 1 over root 2. And so we know, based on what the above, that since we have an angle in quadrant number 2, where cosine is negative, so we have cosine 11 pi over 4 is going to be equal to negative 1 over root 2. And from there, we know that the secant ratio is simply going to be the reciprocal of what we just have. And so that will be negative root 2. Okay, so next we're going to look at trigonometric identities. We already looked at the Pythagorean identities, so we'll skip over that. And these are the important ones, the even and odd identities, the sum and difference identities, and finally, we also have the double angle identities. So the types of questions we'll be seeing are something like this one here. So it says, prove the double angle identity for sine. So we're going to start with sine 2x, which we know is the same as sine x plus x. And here we can use the sum and difference identity for sine, which gives us sine x cosine x plus sine x cosine x. Now we have two like terms, we can combine them, and finally we're left with 2 sine x cosine x. And that's the proof of the identity. Other questions that we have about trig identities that we have seen before are ones such as finding the exact value of sine pi over 8. So what we'll do is we'll begin with actually cosine pi over 4, which we know the value of is just 1 over root 2 from an earlier example. And we're actually going to go ahead and use this example, this identity right here. So in our case, 2x is equal to pi over 4, so that x is equal to pi over 8. So if we were to apply the identity, then the right-hand side will be 1 minus 2 sine squared pi over 8. So from here, we know the exact value of pi over 4, that's 1 over root 2. And we can subtract 1 from both sides as well. So what we're going to have is 1 over root 2 minus 1 is equal to negative 2 sine squared pi over 8. Okay, so next we're going to rewrite the left-hand side over a common denominator. So we can have 1 minus root 2 all over root 2. Like so. And then the right-hand side stays the same. And then we're going to divide both sides by negative 2. So we'll have root 2 minus 1 all over 2 root 2 and that's going to be equal to sine squared pi over 8. So we can just square root both sides here. But before we do that, we're going to go ahead and rationalize the denominator to make this a little bit easier. We're going to multiply every term by root 2. So root 2 times root 2 gives us 2. 1 times root 2 is root 2. And in the denominator, the root 2 times root 2 gives us 2. 2 times 2 is 4. So we simply have a denominator of 4. And finally, in the last step, we are going to go ahead and square root both sides. So we know that sine pi over 8 is equal to the square root of 2 minus root 2 all over 2. Something like this. Actually, sorry about that. Let's go ahead and fix this slightly. That's better. The question that we might have is it positive or negative, the square root of 2 minus root 2 over 2? But it isn't, since we know that pi over 8 is in quadrant 1, and sign ratios there are positive, so we're only going to keep the positive result, which is what we have right here. Okay, next, we're also going to be looking at the graphs of trigonometric functions. There are 3 main ones, and here they are. So the first one we have is, of course, just y equals to sine x. And then from there, we also have y equals cosine x. And the third graph is y equals tangent x. Okay. So just really quickly, the domain and range of each one of these. The domain for both the sine graph and the cosine graph will be x is an element of the real numbers. Very familiar. Now the range for both the first two functions will be from -1 to 1, inclusive. So here we can write this as an interval or as an inequality. So in the first case, as an inequality, this is what it looks like. And here, same thing, but written as an interval. Be y is an element of from -1, sorry about that, to 1 inclusive. A tangent function, of course, is a bit different. There are restrictions on the domain. So we know that the domain is x cannot be equal to pi over 2 plus n pi, where n is an integer. And then the range is y is an element of the real numbers. Okay, just a couple more examples here. So, just a quick note about the secant, cosecant, and cotangent graphs. We will need to know what they look like a little bit, and we will also have to be able to find the domain and range. So, very quick example here about the domain range of this cosecant function. So the first step is going to be rewriting it as with a sine ratio. So this will be 2 over sine 3x and then minus 1. So the domain, as a result, is going to be wherever sine 3x is not equal to 0. Otherwise, we have a non-permissible value. So we know that then 3x cannot be equal to n pi, because if it were, then the sine ratio will be equal to 0, and that's not allowed. And then we can simply divide both sides by 3, so x is not equal to n pi over 3. Okay, so about the range is a bit more complex. So we'll start with the range of just a cosecant function. And that will be from negative infinity to 1, or, sorry, negative 1, or from 1 to infinity. And of course, from there, we are going to multiply by 2. Which means the range is going to be from, so this is the range, sorry about that. From negative infinity to negative 2 instead of 1. Notice that the 2 here is a vertical stretch. And then it will also be from 2 to infinity. And finally, we're going to subtract 1. So then the range is going to be from negative infinity to negative 3. So we subtracted 1. And then from 1 to infinity. Again, 1 was subtracted from that bound as well. The 3 here is a horizontal change, so it's not going to change the range at all. So this right here, this expression, is going to be the range of the function. Okay, so last example for this first half, we're looking at a trigonometric equation. So it says to solve cosine square x minus sine square x equal to 1 on the interval from 0 to 2 pi. So we're going to go ahead and use the identity where cosine 2x is equal to the expression on the left-hand side. And that's, of course, is going to be equal to 1 on the right-hand side now. So this is just the double angle identity for cosine. So what that means is 2x is going to be equal to 2 pi n. So quick note here, the first step, again, we use the identity. And the second step here, we solved what happens if cosine x is equal to 1. And of course, from there, we can divide both sides by 2. So x is going to be equal to n pi, or pi n, the way that it is written. So since we are given the interval from 0 to 2 pi, our solutions are just going to be 0 and pi, but not 2 pi because it is not included in the interval. And that's it. So since trigonometry was a large part of the previous course, we will continue with the second half of this review in the next video. So once again, thank you for listening.